Okay, we'll see if this works. I'm going to try and record it just in case other people want to hear questions later. So they'll just get whatever happens on the board, and they'll just hear the audio. They won't see any video or anything. So talk to me, Amanda. Go ahead.
Okay, so I know I'm supposed to find the average rate of change of the traffic flow, but so we have a rate.
Did you say, stop for 1 second. Did you say 1B or 1D?
1B.
Like D as in dog?
Yes.
Okay, I was on the wrong one, so hold on a second. Okay, hold on. Let me catch up to you. Okay, say it again. Sorry.
So I know I'm supposed to find the average rate of change of the traffic flow, which is a rate. But so we have the equation for that, but I was thinking you do like 1 over 5, then the integral from 10 to 15 of f of t d of t. But then you're finding an amount, not a rate. And then I was getting confused on how to take the derivative of f of t to make it so that you'll have a rate at the end.
Really good question. Let me just talk for a minute, see if this helps. Hold on. Okay, what they like to test you on, okay, I think your understanding is just fine. What's happening is they like to test on a few things that are very similar. So let me share the screen. I'm up here at the board and I forgot to share the screen, so here we go. You're thinking like, oh, that's great, Mr. Smith, but I can't really see the board. So, okay, this is it. Can you see it now?
Yes.
Okay. Okay, so what they want to test you on is, now technically this year they won't actually be testing you on finding the average of something. So even though we learned about that, they won't technically test you. I'm putting some of those questions on the FRQ practice tests simply because they are usually tied to something they will be testing you on. So for example, you are correct. In this problem, they set it up kind of weird. It's meant to try and get you confused. It's hard to describe what would be the amount in this case. I know that the rate is what they gave me. So the rate here is capital F. And I know that the units of the rate are cars per minute. And this rate tells me how fast cars flow through the intersection. The amount over here would have to be units of cars, but I'm not really sure how to describe the amount, so won't worry about that right now. If they wanted the average of the rate, like the average of the traffic flow, the average of the traffic flow is what you were thinking of. So if I want the average of the traffic flow, because the traffic flow is F, I would need to integrate over the time period they're talking about. This would become 1 over 5 because the time period is 5 minutes long.
Can you scroll down?
Oh, you can't see that?
Yeah.
Gotcha. Hold on.
Oh wait, there we go. I got it.
Are you good
I got
now?
mine. Yeah.
No worries. So if you were trying to find the average of F, like what's the average traffic flow over some time period, you would do an integral like this. What they're asking for is slightly different. They want the average rate at which F changes. So they don't want the average of F, They want the average rate at which F is changing, which is different. Somebody asked to join here, 1 second. Not sure how this is going to work, but we'll just keep working on it. So.
Sounds good.
Nope, it just says there's 3 of us, and one of them is the presentation, so we're good. So it's still just UI in the whiteboard is what 3 means, apparently. So.
Cool.
So average of the traffic flow is this. Average rate at which the traffic flow changes is more of a common sense thing. It's like saying, well, going back here, it's like saying, well, what is the traffic flow at minute 15? Well, the traffic flow is 85, just rounding. But then 5 minutes earlier, the traffic flow was only 78. So that means over those 5 minutes, the traffic flow went up by 7. But it happened over a 5-minute period, so on average, this is how fast the traffic flow itself is changing. And so this is referring to the rate of the rate. But it's not the instantaneous rate of the rate, it's an average rate of the rate. That's why we're here with units of cars per minute every minute. So that's what they were asking you to find in part D, was this, instead of finding the average of the rate itself. So the difference, I'm saying it again, but the difference is average versus average rate of change.
So it's kind of like we're finding like a secant slope.
You are definitely finding a secant slope, absolutely. Let me draw a picture of that. The more we talk, the better it will sink in, and as long as you have time, it really is better to keep talking about it.
Mm-hmm.
Okay. 1 second. Let's go. This is 2004 1D. It's a really good example of how on, can you see the calculator? Amanda, can you see the calculator?
No.
So apparently they'll have to share that. 1 second. I was hoping it would automatically share, but it does not. So.
Bet.
So you see me again, right?
Yep.
Should see the calculator here in a minute.
Yep, I see the calculator.
Awesome. So I'm just going to put in this problem. 1 second. Okay, so you see the graph?
Mm-hmm.
So this is a graph of capital F, showing that the traffic flow is changing. It's different at different times. And in this particular problem, if they were asking for the average traffic flow, again, it would have been the 1/5 integral of capital F. And you would have been using your calculator to basically find all of these different values of the traffic flow, and you add them all together, and then you divide by how many you added up. That would be finding the average of the traffic flow.
Mm-hmm.
Because they said find the average rate of change of the traffic flow, it's what you said, it's a secant slope. You literally are taking this graph of F, and you're saying, well, let's trace. Let's go to time 15, where the flow is 85. And then you go back to time 10, where the flow is only 7. So it's a secant slope like this. Can you see my pen?
Uh-huh.
Yeah, you're finding the slope of that line.
You're just doing like S of 15 minus F of 10, and then you just do like kind of like change in Y over change in X.
Uh-huh. Because you're finding on average how fast is F changing between those two times. So I'll go back to the whiteboard. So this equation right here is what you said. This is F, capital F of 15, subtract capital F of 10, divided by the time period.
Oh, okay, that makes way more sense.
The formula I posted here, off the golden notes, is exactly what you're saying. We're finding a secant slope. We're finding, now the symbols here are different because it's the golden notes, but how they apply to this problem is you think of this as being capital F. So we're finding the average rate of change of capital F, which means we have to take capital F of B, subtract capital F of A divided by B minus A, where A and B are the 10 and the 15. That's what we did.
Okay. That makes way more sense.
Good. That's the whole idea.
I was like, well, it's an amount, and it doesn't work.
That's one of their favorite things to test you on, is trying to see if you can understand when they're asking for average rate of change. It's tricky, but that's how it works in this problem. And it'll keep showing up on practice FRQ tests, so every time it shows up, if you end up getting mixed up again, don't worry about it. Just keep asking about it. With a few examples, eventually you start to say, okay, now I'm starting to see the difference, so it's no big deal.
Yeah, that's good. That makes so much more sense. It's like, I got really stuck.
No worries.
And then, let's see. Still no one else is here, so I guess
You're good. It's all you.
Okay.
Yeah, I'm watching my remind in my emails, see if somebody's having trouble. No one's asking, so you're good.
You know, I can't. I'm doing stuff like this today with Katie. I could text her because.
You don't need to worry. I'm more than happy to help you all by yourself if you have questions. So I don't really care. So you're done with that one, right?
Yeah.
Okay, I'm going to stop that video and see if that worked.